Hello students, I'm going to start with class 12 with part 2 of NCERT, CBSE syllabus of course, and that is haloalkanes, haloarenes. Organic chemistry is very essential for class 12 students because it covers up 33 marks out of 70 in their board exam, which is almost a 47 to 48% of the entire paper. So organic chemistry is easy to study if you understand the concepts in depth. But you should be very careful while you are answering the questions of organic part because it is easy to lose marks as well. So all the best. Welcome all of you. The first unit of organic chemistry in class 12 is haloalkanes and haloarenes. To start up with this unit, we need to know the meaning of the terms haloalkanes and haloarenes. By the term halo, it's halogen. We mean halogen. So they are halogen substituted alkanes. Alkanes have a general molecular formula CnH2n plus 2. We know that this is the general molecular formula of alkanes. The moment we talk about haloalkanes, it is one H substituted by X. So we get CnH2n plus 1X. They are haloalkanes. So halogen substituted alkanes are haloalkanes. Haloarenes. Arene system goes with benzene system. So C6H6 is benzene. So when we substitute one H of benzene by halogen, we get C6H5X. So this is an example of haloarene. It's an example of haloarene. But we need to remember one thing, that when any halogen atom is directly attached to the benzene ring, we will classify it as haloarene. When any halogen atom is directly attached to a benzene ring, it forms haloarene. So let us discuss about classification of haloalkanes and haloarenes. It is based on two things. First thing is on the number of halogen atom. If there is only one halogen atom present in the compound, it is known as monohalo compound. So it will be monohaloalkane or monohaloarene system. If this single halogen atom is attached to a benzene ring, like in C6H5X, then it is monohaloarene. Dihalo means there are two halogen atoms in the compound. It can be further classified as geminal dihalides or vicinal dihalide. Now, geminal dihalide means both the halogen atoms are attached to the same carbon. If to the same carbon atom two halogen atoms are attached, then it is geminal dihalides, and it is also known as 1,1 dihalides, or for haloalkane system it is known as alkylidene dihalides. So I can write one X here, another X here. To the same carbon atom I am writing 2X. So this is under geminal dihalide because two halogen atoms are present in the same carbon atom. If two halogen atoms are present in 1,2 position, 1,2 position actually doesn't mean your nomenclature wise 1 and 2 position numbering. 1,2 position means adjacent positions. It means adjacent positions. If the halogen atoms are present in adjacent position, adjacent carbon atom, then it is vicinal dihalide, and it is also known as alkylene dihalide. Now next comes trihalo compounds. There are three halogen atoms, so it is under trihalo. And the very important part is based on hybridization of the carbon atom that is holding the halogen atom, classification is being done. If this carbon atom that is having halogen attached to it is sp3 hybridized, then it can be alkyl halide, which again can be 1 degree, 2 degree or 3 degree alkyl halides. It can be allylic halides or it can be benzylic halides. If the carbon atom holding the halogen atom is sp2 hybridized, then it can be vinylic halide or it can be aryl halides. So this part, hybridization of the carbon atom holding the halogen atom, will be again explained elaborately. One example of geminal and viscinal, let us see. Dihalogen compounds can be classified into geminal and viscinal, we have already said. So I did not classify them into geminal and viscinal. I have given example of two compounds. First is under this category, alkylidene halide. Alkylidene halide. It's isopropylidene chloride. So isopropyl linkage and alkylidene halide means it goes under geminal dihalide. So it's geminal because this carbon atom is having two halogen atoms with it, and if I number it as per the nomenclature, IUPAC nomenclature, it is carbon number 2. So 2,2 dichloropropane is the IUPAC name. The next example is alkylene dihalide, propylene dichloride. So this is alkylidene halide and this one is alkylene dihalide. So in propylene system, 3 carbon atoms, meth, eth, prop, so 3 carbon atoms. It is an alkylene dihalide, means vicinal. So in vicinal, in this example of vicinal, what we have seen that carbon number 1 and 2. So whether I keep the Cl atom from right hand side or I keep it from left hand side, it will be carbon number 1 and 2 only because it has in total 3 carbon atom. So as per the nomenclature rules, IUPAC rules, I have to number from the carbon atom having Cl. So this is 1,2 dichloropropane. Classification based on hybridization of the carbon atom having halogen attached to it. This carbon which I have marked. Now this carbon atom, if it is sp3 hybridized, the first classification goes that it can be haloalkanes or alkyl halides having the general formula CnH2n plus 1x. CnH2n plus 1x, and it can be 1 degree, 2 degree or 3 degree alkyl halides. How do we know that whether the alkyl halide is 1 degree, 2 degree or 3 degree? 1 degree is known as primary alkyl halide, 2 degree secondary and 3 degree tertiary. The carbon atom to which the halogen atom is attached, the carbon atom to which the halogen atom is attached, if that is directly attached with one carbon atom, it is a primary alkyl halide. We can see it is directly attached with only one alkyl group. So obviously it is directly bonded to only one carbon atom. So it is a primary alkyl halide. Secondary means it is directly attached to 2 carbon atom belonging to the same or different alkyl groups. That is this carbon atom is a second degree, 2 degree or secondary carbon atom. That makes the alkyl halide secondary alkyl halide. Now the carbon atom to which the halogen is attached to 3 alkyl groups. So I can say it is bonded to 3 carbon atom, and so it is a tertiary alkyl halide. So this is how we are going to see. Many have the habit of seeing that in a tertiary this carbon atom is having no hydrogen, in a secondary this carbon atom is having 1 hydrogen, and in a primary this carbon atom is having 2 hydrogen. That is an obvious consequence because in a 1 degree 1 hydrogen atom is replaced by 1 alkyl group. So it's better, I will insist you to see the carbon atom to which the halogen atom is attached is directly attached to how many carbon. If it is directly attached to 1 carbon, be it a part of 1 alkyl group, that is a primary alkyl halide. If it is attached to 2 carbon atom, it's secondary, and if it is attached to 3 carbon, it is tertiary. Now here is a question of identifying what type of carbon is this, the one which I have marked. Hence, what type of alkyl halide it is. Obviously, they are cyclic examples, so they are cycloalkyl halides or halocycloalkanes. So here in these cyclic examples, the carbon atom which is having the halogen atom, we can see it is directly attached to 1 and 2. So you have to say how many degree carbon it is. This carbon atom is also directly attached to 1 and 2. So predict how many degree carbon it is. Next, the carbon atom to which halogen attached is sp3. Under that, we have two more classification. One is allylic halide. Now, allylic is a position. How to identify the position? This is allylic position. That means this carbon will be sp3 hybridized and it will be attached directly to some sp2 carbon. So when to this position there is a halo atom attached, it is known as allylic halide. That means halogen atom is attached to allylic position. So how did I define the position? I said the halogen atom is attached to some sp3 carbon which is attached to some sp2 carbon. So this is again another example of allylic halide which I have made for you. So we should be very much careful about the ring that we are drawing. Every time I am making a 6-membered ring, it's not necessary that it will be a benzene ring. So be careful when you are drawing the structures or naming the structures. So this is the position of the halogen atom. So the carbon atom to which this halogen is attached is sp3. And here is a double bond. That means it is directly attached to one side to some sp2 carbon. On the other side, it is sp3 carbon. So that is not the factor because this is not in that case any allylic position. So allylic position will be this. Why? Because this carbon atom is sp3 hybridized to which another sp2 carbon is attached. Next comes benzylic halide. Halogen atom attached to benzylic position. Just as I have told allylic is a position, benzylic is also a position. The carbon atom which we are defining as a benzylic position is sp3 hybridized and will be directly attached to a benzene ring, some aromatic ring. So this position is my benzylic position. And since there is an halogen atom attached to this benzylic position, it is an example of benzylic halide. A halogen atom attached to the benzylic position makes it benzylic halide. Suppose I give you this example. This I can see is a benzene ring. Fine. Now to this ring, I make another ring over here without any pi bond. And I give halogen atom to this position. So can we say it is the benzylic position? Because this is sp3 carbon and it is directly attached to a benzene ring. So yes, this is also a benzylic position and it's a benzylic halide. Now please note over here, to this carbon there are two hydrogen attached. So these two hydrogens are replaceable hydrogen. If I replace one hydrogen by any alkyl group over here, then it becomes somewhat like this, that here there is one H, here there is R and here there is X. So when I have substituted one H by one alkyl group, then this carbon atom becomes 2 degree because it is directly attached to 1 and 2 groups, that means 2 carbon atoms. I hope the explanation part was good for you. It was helpful. If it is helpful, I will insist you all to drop your comment in the comment box. That will help me to make more videos like this. Thank you. Happy learning.